Hi guys, Mrs. Thompson here, and I'm here to talk to you about naming acids, which is also called acid nomenclature. We've actually used nomenclature. That's just the system of naming when we were naming ionic compounds. Right down here you have a little fun fact about Venus. It rains sulfuric acid on Venus, which we'll learn how to make the formula of sulfuric acid today. And it snows some heavy metals, so not quite an environment for life. Okay, so let's define an acid. An acid is a polar covalent compound. Remember that covalent compounds share electrons, but polar covalent compounds do that not so evenly. One atom holds on to the electrons more than the other in a polar covalent bond. These are things that are acidic when you put them in water. So it says when aqueous. Okay, when you're looking to decide if something is an acid, what you'll notice is the formulas will begin with a hydrogen atom. Not all compounds are like this for acids. There are some organic acids, but the ones that we're going to deal with will start with a hydrogen. Okay, this is a flowchart that I would like you to draw. So make sure you pause it, draw the flowchart. Okay, so what this flowchart is it kind of just goes through a system of naming. The first thing says, does the anion contain oxygen? So the anion would be anything after hydrogen, and it's either no or yes. If that's a no, it doesn't contain oxygen, then it's what we call a binary acid. Binary acids are acids that only have two elements in them. That's why the prefix bi. So binary acid. What you would do is you would put a prefix of hydro on it, plus the anion root, that's part of the element's name, and then you add ic to the end of that, and call it a hydro something ic acid. If the opposite's true, it does contain an oxygen, then you have what we call an oxy acid, or sometimes referred to as a ternary acid because it has at least 3 elements in it. Okay, so what you're going to do is you're going to look at that acid, figure out what the anion is. So that's everything after the hydrogen. If the anion ends in "ite", then you're going to change the name ending to "ous" and add acid at the end. Notice it does not have the prefix of hydro. That's simply reserved for binary acids. Okay. Then if you have a name ending that ends in "ate", we'll change those 8 ions into ic, and then add acid. Okay, something that helps me remember ic acids versus ous acids is this. It's just a little mnemonic. I ate something icky. So ate and ic go together. I ate something icky. The 8 ions will turn into the ic acids. And then you have to remember the opposite's true for the ite. Those turn into ous. So we're going to do some examples using this flowchart. So make sure you write down the examples and then we'll go through them. Okay, so we have HBr, and notice they all have AQ next to them. That's because they're dissolved in water. And in order for them to be acids, they really need to be dissolved in water. We should make the habit of writing AQ next to it, although sometimes you won't always see that. What I'm going to do is I'm going to draw a line to separate the cation, well, not so much the cation, to separate the hydrogen from the anion so that I can see what the anion is, whether it is something that contains oxygen or if it's an ite or an 8 polyatomic ion. So I'll draw a line after hydrogen, and I notice it's just bromine after that. So for my flowchart, does the anion contain oxygen? This is a no. So I'll add hydro, the root, ic acid. So I'll do that. Hydro. And then the root for bromine, or the bromide ion, would be brome. So we've got hydrobrome. And then we add ic acid. So this is hydrobromic acid. And this is a binary acid. Does not contain oxygen. It only contains 2 different elements. Okay, next one. I'm going to draw a line after the hydrogen. Notice even though that's 2 hydrogens, it's drawing a line after H. And now I see that everything else after that is going to be my anion, CO3. Well, I need to look that up on the polyatomic ion sheet, or I have that memorized. CO3 is carbonate. It looks like this, really, CO3 with a 2- charge. What the hydrogen has done is it's balanced out that charge. It's no longer 2-, so now it's no charge in the formula. So what we're going to do to carbonate is we're simply going to change it from carbonate to carbonic acid. We're changing the 8 to ick. I ate something icky. So this acid is carbonic acid. Okay, next one is H2S. Draw a line after the hydrogen, and we have just S. That does not have oxygen. So it says hydro plus anion root plus ick, and then acid. So this will be hydro. The root for sulfur is actually sulfur in this case. So it's hydrosulfuric acid. Okay, number 4, draw a line after the hydrogen. And everything after that line is my polyatomic ion. Notice I have oxygen in this one. This is a yes. We'll check the anion ending. SO4 with a 2- charge is sulfate. And sulfate ends in 8, so we'll change that into ick. So it'll be sulfuric acid. Okay. Notice that from sulfate, it didn't go to sulfic acid. It actually brought back the whole root, sulfuric acid, all the way to the R. There's one other element that's going to do that, and that's phosphate. It doesn't go to phosphic acid, it goes to phosphoric acid. Here we have H2SO3. Draw a line after hydrogen, and that's SO3. If I look that up, that's sulfite. And notice this has oxygen in it. That's why I knew it was a polyatomic ion that I had to look up. The ite turns into OUS, so we'll take the full root of the word sulfur, sulfurous acid. Next, what we're going to do is we're going to change it from the name to the formula. Before we do that, I have to draw attention to this cute little joke cartoon. It says, what do you call an acid with attitude? Amino acid. That's just a little bit of acid and biology humor there. Okay, so here we go. First thing, here's what's going to happen. If it starts with hydro, so you're taking the name now and you're turning it into the formula. If it starts with hydro, what you know is you have 2 elements in it. It's a binary acid. You have hydrogen and some sort of nonmetal that you can look up on the periodic table. If it does not have hydro in it, then it must be an oxyacid. And an oxyacid is made up of hydrogen plus a polyatomic ion. And what you're going to do to figure out the formula is you have to balance out the anion. And that is by adding as many hydrogens, or H pluses, that you need to cancel out the charge on the anion. Okay, let's try some examples. First one, phosphoric acid. What I'm going to notice here is that it does not have the prefix hydro. And since it doesn't have hydro, that means that this is an oxyacid. I'm going to use hydrogen plus a polyatomic ion. Which polyatomic ion? Well, that we can tell by the ick in the name. Remember, I ate something icky. So that was an 8 ion. Since this is phosphoric, this must be phosphate. So then we need to figure out what is phosphate. Should have this one memorized, but here it is, PO4 with a 3- charge. And then we're going to put hydrogen in front. Now, when I was talking to you about acids, I said they always start with a hydrogen. So I'm going to put hydrogen in front with its charge. And this isn't my formula. I'm not done yet. What I am stating is it's going to help me figure out how many of each hydrogen I need. So since I have a 3- charge here, and this is a 1+, I'm going to need 3 hydrogens to balance out that 3-. So 3 positives to cancel out 3 negatives. And so what I'll do to write the formula is 3 hydrogens and then phosphate. And then to finish it off, we need to put a Q next to it to state that this is an acid and acids are dissolved in water. Next one is hydrofluoric acid. So here I have the prefix hydro. I also have the ending ic. So this is a binary acid. There are only two elements involved, hydrogen and a nonmetal. So the nonmetal would be fluorine or the fluoride ion. So let's find out what those are. That's F minus for the fluoride ion. And then if we put H plus in front, we're going to figure out how many we need. So 1 plus and 1 minus, those are going to cancel each other out. And so that formula would just be HF. 1 hydrogen, 1 fluorine, and we add AQ to say it's aqueous. Okay, next one is iodous acid. The OUS, well, first, the lack of hydro tells me that this is a ternary acid or an oxyacid, where I have hydrogen plus a polyatomic ion. So that polyatomic ion, if it's coming from OUS, means that was an ite ion. So what is that? Iodous? Well, that's iodite. So what is the formula for iodite? Here it is. IO with a 2 or IO2 with a -1 charge. We need hydrogen. And then we balance out that charge. So 1 hydrogen, 1 iodite. That's AQ at the end. Then we have the next one, which is perchloric acid. It has PER, per, and ic. It doesn't have hydro, so we know that is a polyatomic ion. That per must be coming from the polyatomic ion, not from any naming part of the acid. So we're going to look up perchlorate instead, because ic came from 8, so we need perchlorate. And perchlorate is ClO4 with a 1 minus charge. We're going to balance that out with hydrogens. It's just going to take 1 hydrogen for every 1 perchlorate. And so that'll be HClO4 and then AQ. Okay. Hope that was clear enough. Bring your questions to class. Have a great day.